Hello. Yes, fantastic. So this is an exciting one, PFAS. We're going to be talking about the PFAS challenges in the industry. It's a topic that is already receiving a tremendous amount of attention globally. And it all relates to two-phase immersion cooling. Two-phase immersion is a technology which is focused on the real high-density chips, right? It works based on phase change, and it currently has the highest potential cooling performance across the immersion spectrum. Not just immersion, also cold plate contains two-phase technologies. And there is a strong interest in two-phase to facilitate the GPU ecosystem, the high-density GPU and OAI platforms. Think of ChatGPT. The generative AI is really driving the growth of this market. But there are some really strong hurdles to overcome. And the biggest hurdle to overcome is the challenge related to PFAS, part of the forever chemicals family. And there are new regulatory actions which are focusing on PFAS. So I'm going to start with what is PFAS. And Brendan, I'm gonna ask you for a little bit of help because can you pronounce it for us? I'm probably not the only one who's going to be struggling with it, so please do it in the microphone, right? This is your expertise. It stands for?
It's going to be per polyfluoroalkyl substances.
Thank you very much. I'll be introducing the panel in a second, right? So thanks for that. So, yeah, PFAS sounds better. It's easier to pronounce, right? So, but these are man-made chemicals which are used in an incredible array of products. It turns out that it's pretty much everything that we do on a daily basis. Everything in our households relates these days to PFAS materials. And the trick is they don't break down. They're forever chemicals, right? So why is it being regulated? Well, because of that environmental persistence. PFAS chemicals tend to stay in the environment. They tend to not disappear, and there are health concerns related to it, especially when it comes to bioaccumulation. This is something that drives a lot of the regulations that are currently being formulated. And all current two-phase fluids that are currently being used are PFAS fluids. So obviously this is an enormous threat. And regulations are in the making in Europe and in the United States and are receiving a lot of attention. I think it's really hard now for even somebody who's not familiar with data center technology to not have heard about PFAS, right? European Union has been starting the legislation process since 2021, similar to here in the United States. And these legislations, these regulations are running pretty much parallel with similar timelines. In the US, looking at potentially this year for some steps, and Europe pretty much looking at 2025 for some major changes in the industry. So this is causing a lot of questions. This is generating a lot of questions, especially in the immersion community or in the liquid cooling industry. How do these regulations affect our industry? Will immersion technology or cold plate technology even fall under these regulations? Should we lobby for more relaxed PFAS regulations, or are there alternatives even for these two-phase fluids? Maybe not today, but maybe tomorrow. Who is doing the research on these alternatives? So I know that there are some developments going on regarding hydrocarbon-based fluids to perform in TFAS, but there is a lot of concerns about flashpoint, which these things really take time. So the real question is that everybody seems to keep asking, hey, is this the end of two-phase technology? I would argue no. Not really, because it's still a necessary technology. But we do need to take some action. And one of the first things that we need is some more transparency. For the past year, we've been struggling with getting involvement from the two-phase technology domain in the project goals. not just in the Immersion project, also in cold plate, because hey, this is a sensitive topic at this point in time. But to make sure that we can progress and advance these technology developments, we're going to have to talk about it. We're going to need to be familiarizing ourselves with these challenges and try to figure out what the next steps are. So to facilitate this, we're going to have a discussion with the panel that we have right here. And I'm really proud that we've been able to pull this panel together. We got Cheng from Meta, which you've already seen in the previous sessions. I'm not going to do the full introduction because it's going to take too much time. I'm going to leave this slide on. So if you want to know a bit more about who these people are, most of you will know them already from the various booths and other presentations. We got Cheng from Meta, we got Mohan Kumar from Intel, we got Sam Allen from Wesco, and we got Brandon Marshall from Kumar. And all these people have a lot to do with PFAS challenges in the day-to-day business. And I would like to start with a question towards Sam. Sam, with these PFAS regulations, what is the concern within your business regarding these PFAS developments? How is this posing you with challenges?
I think honestly, the first thing that we have to say as an engineering business is that there's a real distinct lack of understanding as to what a PFAS really truly is, right? Whoever coined the phrase two-phase immersion cooling genuinely deserves all the money in this room, right? It's a very intelligent thing to do. But there's a lack of understanding around what it truly is, what the implications are of using it, how you implement it properly, and the safety around it. And ultimately, Rolf pointed out the wonderful slide earlier, what the global legislatory approach has been so far. I just have to pick up on that super quickly, but everyone, so I grew up in refrigeration and air conditioning. I grew up in a time when, R22 was a thing, and it was used far too regularly, and it was released to atmosphere far too regularly. But what actually happened was when, the European Union went and said, we're going to ban this. You need to find a replacement. Everyone went, no, you're not. It's not going to happen. We all use it every day, every week, every hour. How can you replace that? And it happened. And then they came again for R134A, 404A, 410A, 407C. Every single component in every single fridge, in every single air conditioning unit in the world used those gases. Did it stop the legislation going through? Absolutely not. And meant in the nicest possible sense, we're an infantile industry, sorry. We've got a huge way to go. So anyone in the room knows a little company called LG Electronics or Samsung, Mitsubishi Electric. Small people, they were lobbying for years to try and stop that change from happening. And we don't have a unified voice as yet. So, the question is really, is the legislation going to stop? And there are other people on the panel that deal with that a lot more than me, but I'm going to pass over to Brandon, because he can probably give you a much more educated answer than I can.
So, Brandon, I think that's a really good point, right? So, Brandon, do you think, is this PFAS regulation going to make a U-turn?
Yeah, that's difficult to answer right now. The legislation as it's written predominantly in Europe is so broad that it covers everything ranging from polymers, materials that a lot of you are probably using on communications cables today, all the way through etching gases, impacts the automotive industry and battery production, and then of course fluorinated fluids and gases. The European legislation, where I'll probably focus the most because it's the most mature in the process right now, really is a shotgun approach at legislating, right? It's kind of taking a very broad definition that encapsulates a lot of everything, okay, based on an older definition that was put out there several decades ago. And it doesn't take into account several factors, such as risk-based factors. How are these products being used? Where are they being used? How are they being controlled? And what's the actual risk to people and to the environment, right? Just to give you an example, when you look at the European definition, it encapsulates over 10,000 different compounds today, right? Compounds that we use in our everyday lives, all the way through what industry is using today. So it's really broad. Now, paralleling that to EPA and where EPA is stepping in and how they're approaching this is they're taking a risk-based approach. is this dangerous for human health? Is it dangerous for the environment? What's the application and what's the controls? So it's difficult to say if it's going to U-turn. I see articles every other day that say, oh, there's going to be a change in the overall political spectrum in Europe, especially with everything going on, so maybe it'll be stopped. Others say it's going to proceed forward. But I think we'll gain a lot more clarity on it as we move into 2023, and 2024 rather.
All right, great, thanks for that insight. So what I'm really curious about, Mohan, as Intel, as a chip manufacturer, delivering these really high-performance chips that would really benefit from this technology, how does these PFAS regulations affect the Intel roadmap for this chip development?
So, I mean, I think like many folks probably in the audience, we are at the receiving end of it. We are not a chemical manufacturer. We are a silicon manufacturer, right? So, at the behest of our customers, we are trying to put these into whatever cooling medium that they would like it to be. And so we are kind of, this is an uncharted territory essentially for everybody in the industry, because we don't know where to, where do you focus, right? I mean, of course, the customer comes in and says, this is the chemical, and there are all these regulations coming in, and it's very hard to then put your energy as a company or even as an industry behind something that may not be there in the next 2 or 3 years right? So this is where I don't know if it's so much a single company problem. To me, what I would like to see is more of the engagement of the two-phase chemical folks in bodies like this, like OCP. So we see your point of view and we can incorporate your point of view, and we know a little bit more about what those things are, because otherwise, the dominant voice is whatever is amplified in the media.
Yeah, I totally agree, right? We do need the participation and we do need the collaboration in an open domain, right? So, Cheng, you just did we just seen some presentations from the side of Meta, and Meta is looking at immersion. Especially, you guys are going to be big on the artificial intelligence wagon as well, right? So, what is your view on this? How does this affect the roadmap for Meta?
I would say it's painful. It's really painful, and undoubtedly, a two-phase immersion would have to be carefully examined. Because if you look at our site, we have majority of our site, data center sites in the US and in EU. So it's definitely a big impact. And not only two-phase immersion, we basically have to carefully evaluate more than half of the single-phase immersion fluid options. And then the liquid cooling is not worry-free. In the cold plate, in our, let's say, facility water loop, secondary loop, the load of materials also being impacted, though not the coolant itself. Even the air-cooled products as of today, they are also being impacted. It's a massive impact, and our compliance team has compiled a really long list of materials being impacted or potentially will be impacted. And there's a lot of efforts from our function teams to try to examine if they comply with the regulation or if there are any alternatives available.
So what do we know about the alternatives in the market? What are the developments that we're looking at in the market? What is being tested? Maybe Brandon, how do you see the ongoing development of these fluids going forward?
Yeah, definitely. Right now I would say probably one of the biggest points that industry and regulators need to settle on is what is going to be the operational definition. There's a lot of different things that we can do as an industry and as chemical suppliers to come up with different fluids, to try to find different formulations, and even with fluids that we're working with today, as many of you have stopped by our booth and seen some of the products that we're promoting now. For us to develop, and an important factor to take into play is molecule development, unlike faster processors and things like this, can be decades. It can be 10+ years, no problem at all, to develop a molecule itself. So the big area that I think industry needs to focus in working with regulators is to start working on finally establishing a working definition that accounts for the needs of industry, both on the semicon manufacturing side of things as well as the data center operation side of things, that will allow everybody to start developing in that direction, and so that people are comfortable to be able to move forward and make the necessary investments, right? Everything that we're talking about here, and to Sam's point about the amount of money that's in the room, this is a very expensive industry as well, and the wrong direction could be tens of or hundreds of millions of dollars.
So how can we as a community support and drive this this development and this ongoing innovation? Cheng, do you have a view on that?
I'm not a compliance expert and not familiar with the regulation details, but I would say that we see benefit of the those technologies, what it can bring in terms of sustainability benefits. For example, Department of Energy has sponsored a variety of projects on the clean technology explorations. A lot of universities and companies involved in that, and a major I think multiple projects are involved in two-phase immersion technology or two-phase cold-plate technology. So actually, to see that those applications which relies on the PFAS materials actually can favor sustainability matrix in some way. And me as an engineer will be asking the question is, okay, can this weigh out that kind of side effect? I don't know. It's far more complicated than what I can imagine of. But I would say the technical way, I think there are trade-offs and more details need to be examined.
I'm going to add a little bit to that as well. I think one of the big problems that we have as an industry is perception. The manufacturers I mentioned a minute ago, for a bit of a joke, but also seriously, LG, Samsung, the others, they all use this technology, but they use it in much, much smaller quantities and in very different environments. So if you just take a look at and I apologize, I promise I don't just talk about fridges. You take a look at refrigerator technology, right, over the last 20 years, the move away from an inert gas that if it leaks you never had any problems through to an A2L flammable gas was not a problem. It's in a domestic environment. There wasn't a heat source that could ignite it. The flash point could be relatively low, and that might be 600 watts worth of cooling. How big are the campuses that are going up today? And we have this perception problem as an industry where if you're talking about a gigawatt campus, right, that's not unusual now. Realistically, the questions that get asked are how much power are you using? How much water are you wasting? How much space are you going to take up? This is potentially an answer to all three of those things, because if you're using the right technology, you're going to be using significantly less power. If you're using a higher elevated water temperature for a loop, in order to be able to do this, you're using significantly less water, and it opens up a lot more of the world where you can actually deploy this effectively. And then ultimately the space, everyone's been banging on about high density for years now, but we're finally actually at a point where it's a thing. 50, 60, 70, 80, 100, 140 kilowatt cabinets are being deployed every single day. That takes up significantly less space than your industry standard 8 to 10 kilowatts. So if we can actually all align and become more vocal, because we don't like to shout about the fact that you've got a gigawatt deployment because we're all worried about the industry perception. But if we actually start to educate people around that, there's a huge opportunity to be able to redefine what we do.
So Mohan, Intel's really strongly focused on the sustainability aspects with liquid cooling technology as well. How does that play into this discussion? Because it seems, what Sam is saying, it seems to align, at least to a point, with also what Intel is trying to achieve, right?
Right, and I think you heard this consistently from Intel throughout this conference, right? Liquid cooling technologies has a promise to reduce your the data center cost of cooling at the operational level up to 30%, and that's a big deal because that changes the equation for you in terms of the amount of savings that you bring and the impact that you have on the environment, because savings is not just dollars, it's also in terms of the megawatts or gigawatts that you're putting into your data center. So from that standpoint, we're always excited at technologies that bring up that value in there. We really want to get to a place where we're able to work on technologies, right? So immersion is not equal to immersion equal to immersion. Like if you're going to do two-phase, we need to have a unique cold plate, unique heat sink for it. We need to have a boiling enhancement coating solutions for it, right? So we have lots of technical problems we need to go solve, right? Even if you say it's a cold plate technology, we need to figure out what pressure are you going to operate it at, because one chemical is not the same as the other one. And these are the places that we want our energies going into. And so this is what we are looking for. We want to get to the place where we are focused on that, on those aspects of it. And to the extent that the industry aligns, it's a lot easier to focus on that solution. And so Jessica presented before us on the liquid cooling specification. I would love to see some of this incorporated there from some of the chemical manufacturers here. And then I think, from the liquid standpoint, the thing other than the PFAS, which is the regulatory issue, what we look for is the GWP. And you guys are the experts. I'm told there is HFO olefins are based, I believe. You can talk more to it, that are close to zero GWP, I believe.
I mean, there are zeros. The issue that you've got with it, and actually there's a point that we'll touch on later, when you get down to that level, the gases associated with it are either remarkably high pressure or dangerous for human life.
Yeah.
It's one or the other, basically. So there are different options, but then we'll talk about mission critical and the safety factors that we have in terms of redundancy today. It then becomes a question as to how you actually keep your people safe in that scenario.
Yeah,
So just to follow up on that as well, Brandon, we had a conversation, we had some chats running up to this panel as well, right? In terms of, hey, what does it take to develop these things? And you highlighted some of that a minute ago as well, with the 10-year time span that it might take to develop a molecule. Is there a way that we as a community can help Camurus? You've obviously picked up the glove of running with these two-phase fluids, right? How can we as a community help you with the right direction in this development? Is there a way that we can support?
Yeah, definitely. From my view today, and when you look at the fluids that we're making available and that we've been developing for the last couple years, we've listened to all of your specifications. I'll take, for example, one that we're presenting here this week. Right? It's low GWP, no ozone depletion, it's non-flammable, very, very strong material compatibility capabilities, signal integrity is on par with air, very low risk of creating acids, right, from moistures and other contaminants. And all of those different things, all the attributes of the fluid itself, are things that all of you have asked for. Right. So one of the big things for us as we continue to work through this is, number one, remaining engaged in the process, right, either through Kumars or through other partners that you may have out in the space today to help educate regulators on the materials that are out there now. But number two, and kind of going to Sam's point a little bit, what are some of the different tolerances that are going to exist in the marketplace as we move forward? Are things like flammability going to be acceptable, right? Is material compatibility going to be less of a concern as we move forward? So these are areas that, from a specification view, we have to continue to iron out and make sure that we have an eye on. I'll go back to it again. 10 years is a long time, and a lot can change in that period. So we have to ensure that the specifications that we land on are going to be consistent. They're going to deliver the needs across the value chain, ranging from the Intels and the component suppliers to the tank manufacturers, and then to the end users who are going to be deploying it. And where alternatives don't exist or they're not going to be compatible, making sure that we're being proactive, engaging with regulators to help them understand how these materials are being used, why they're being used, and why they're critical.
All right, thank you very much for that. I think that's really insightful. I would like to move towards ending this direct panel, because I would like to make sure that we have some opportunity for the attendees in the room to also ask you guys some questions that they might be burning with. So I just want to have a quick check. I want to ask you all the question one by one, maybe in one or two sentences. What advice could you offer companies in the two-phase immersion cooling space who are currently grappling with the PFAS challenge? Let's start with you, Mohan.
Okay. So to us, I mean, it's not just two-phase, right? Anything that's liquid cooling, right? We are looking at a few aspects, right? Material compatibility. If it's immersion, definitely material compatibility, signal integrity, reliability, right? Because we're putting it in a new medium, so we need to know that it's overall long-term it's going to be reliable. Environmental, which is sustainability, GWP, and so on, and safety. This is where the flashpoint and things like that come in. If we can address that, any liquid, should be able to qualify under the spec that Jessica presented, right? And those are the things to look for in general, right? And every technology brings in its own challenges. Two-phase, by the nature of the boiling and so on, it does have introduced some challenges, but these are the broad features for you to look for to qualify anything in the space.
Very good, thank you. And Cheng, do you have any advice, very short advice for companies that are struggling now with the PFAS questions?
Well, my advice will be simple. Refer to Joe's wish list, and also we copied from Jessica's slides last year. It's a joke. So.
Right.
I don't know how I can follow on with that from a simplicity point of view. For me personally, I've mentioned perception a few times. We're an industry that struggles with it. Safety is a huge element. So as a piece of information, I'm an F-gas registered engineer. I'm technically qualified to work on refrigerant-based systems, right? I can break them open, I can play around with them, and I can fix them and leave them to work again. I think we have a major concern at the moment where we have a huge volume of people working on this technology who don't hold those qualifications, where it's being deployed into data centers, who don't understand the risks associated with it. And all it will take is one industrial accident, problem, one life, and we will be back at square one. So we really genuinely need to address that very, very quickly.
Brandon?
Yeah, I'll leave everyone with two thoughts here. Number one, especially with the regulations that we're looking at, everybody in the room here has their own subject matter expertise and are helping to fill a piece of this puzzle here, right? The fluid itself is one aspect of it. So one of my big pieces of advice is remain engaged in the process. You would be surprised how little information the regulators have about our industry, about our applications, about our use cases, and the amount of education that needs to be done in order to get them there. So that's one piece. And you can remain engaged in the process through your own accords or, of course, working with some of your partners. The second piece here is to continue to push and evaluate two-phase fluid technologies, right? The best thing that we can do as an industry is understand what the limitations are, what the specifications can look like today and tomorrow, and how we can level set somewhere that we can all proceed comfortably so that we can start bringing this technology to scale. Right, working in this industry, very similar to yourself here for the last almost 20 years of my life, regulations are common. They're going to continue to happen. It's something we're going to continue to grapple with, whether it's going to be energy regulations coming down from the Department of Energy, EPA, ECA, or what have you. So we have to get comfortable with this and make sure that we're collaborating and working together to overcome these challenges versus letting them become significant barriers that are going to continue to slow us down.
Thank you so much. By now we've run out of time, so we're going to have to transition to the next panel, and that's going to be an exciting one as well. But while we're transitioning, if somebody does want to ask a question, just run up to the microphone while we're moving over. Okay. All right. Thank you very much, guys, for joining this panel.